In the vast, silent darkness of the deep, a single drop of blood blossoms like a crimson flower. It is a tiny signal in an immense void, yet it does not go unnoticed. From the gloom, a presence emerges, a shadow given form. A great white shark, ancient and perfect, glides forward, its unblinking eye fixed on the disturbance, a hunter awakened by a scent on the current. This is not just a predator. It is a living marvel of sensory evolution, a creature that perceives its world in ways we can barely comprehend. As it moves with effortless grace, we see the tools of its trade, the lateral line tracking vibrations, the ampullae of Lorenzini detecting faint electric fields, and the twin openings of its nares, gateways to an extraordinary sense of smell. This shark's nose is a masterpiece of biological engineering. Unlike us, sharks do not breathe through their nostrils. Instead, these openings, called nares, are dedicated solely to olfaction. As the shark swims, a constant stream of water is funneled into these passages, flowing over a complex, folded labyrinth of tissue lined with millions of olfactory receptor cells. This immense surface area, sometimes larger than the shark's own skin, is designed for one purpose: to capture and analyze every last scent molecule the ocean has to offer. This allows the shark to build a detailed chemical map of its surroundings, detecting the faintest traces of potential prey, rivals, or mates. The system is not just sensitive, it is brilliantly directional. The shark smells in stereo. With its nares positioned on either side of its wide snout, a scent trail will almost always reach one nostril a few milliseconds before the other. This tiny delay is all the shark's brain needs to compute the direction of the source with pinpoint accuracy, allowing it to instantly turn and home in on its target. This incredible ability has fueled powerful myths, painting a picture of sharks detecting blood from miles away. The reality is both more subtle and just as impressive. A shark can detect 1 part of blood per billion parts of water, an astonishing feat of sensitivity. But that's equivalent to smelling a single drop of blood in a large backyard swimming pool, not across miles of turbulent open ocean. Its true advantage isn't just smelling blood, but interpreting a complex world of chemical signals. In fact, a shark's most crucial close-range sense isn't smell at all, but its ability to detect the faint bioelectric fields of living creatures, even a fish buried and hidden in the sand. Using the jelly-filled pores on its snout, known as the ampullae of Lorenzini. What truly reveals the sophisticated nature of this hunter is not what it can smell, but what it chooses to pursue. Presented with the scent of blood from a wounded seal and the rich, fatty aroma of a large, oily fish, the shark's priorities become clear. Blood may signal an easy meal, but the high-energy scent of fish oil promises a much greater reward for the energy expended. Without hesitation, the shark veers away from the blood and locks onto the more valuable prize, a calculated decision made in an instant. It is a creature driven not by a mindless frenzy, but by a finely tuned instinct for survival and efficiency. With its course set, the great white swims onward, a powerful silhouette against the deep blue. It is a master of its domain, a perfectly evolved hunter disappearing back into the abyss, leaving us with a profound sense of awe for the mysteries it still holds.